Okay, I wanted to put a presentation for chapter 3 to cover strings. The reason is that although strings are introduced in chapter 3, in practice, they're not actually discussed in very much depth. And in order to solve just the problem number one straight out of the way, you actually need to have a little bit of understanding of what strings are and what they look like on the inside. And so I wanted to give this presentation on my behalf in terms of what are strings. This is actually true for any programming language, whether it's C or C++, Java, Python, whatever it is. Many of these concepts are essentially the same. The ideas are the same. So I wanted to dive into this. To be honest with you, many years ago, probably over 20 years ago, when I first started programming, strings for whatever reason gave me a lot of trouble to get the concept. So this is a distillation of what has helped me over the years to reason about this. So what is a string? We'll take a look at that. Why is it called that? It's a little bit of a strange name for me, especially as a non-native speaker. What does it look like inside of a string? And how does the for each looping construct actually work with strings? So what's a string? A string is just a sequence of characters. That is probably the easiest way of looking at it. So if we look at hello, H-E-L-L-O, you have this sequence of characters in there. It starts at 0, and the last character, if we go by position, so the first one, H at position 0, and then E is at position 1, L is at 2, and so on. And then there's a termination, something called a null terminator at the end to tell you when you've reached the end of the string. Because if you don't do that, you sort of don't know when the string ends. And this one happens to be at position 5. So it's just a sequence of characters. And in memory, and this is important, in memory, they actually are all right next to each other, all of these characters. So why is it called a string? So really the best way to think about it is imagine you have a physical string, you're making a bead in a way, and you've cut a string. So you went ahead and you took some yarn and you cut it, and here's your string, and you cut it for a particular length. And now you're going to put beads on it. The first one's going to have H, and the next one E, and the next one L, and the next one L, and the next one O, and you can put another one, which is your terminator, and that's going to be the end of it. So that's why it's called a string. You're sort of stringing them together. You're putting all of these characters on this sort of string vine. Now, if you want to add a character, you have to decide, well, if you add in the front, so you can put it in the front if you have enough of the vine or enough of the string available, but if you don't, you might need to cut a new string and move everything over. That's why later on we'll discuss and see why string copying is actually a little bit expensive, because you have to essentially cut a whole new string wire, put all of the beads and move them over to the other place. So that's why it's called a string. That's probably the best way. You have a physical string with the beads on it, and you can't really go in out of order. That's the order they're in. That's what it was cut to. That's what it looks like inside in memory. So that's why it's called a string. When we're actually dealing with strings, especially in C++, they actually look a little bit different. Yes, there is that actual sequence of characters in the string, the H-E-L-L-O, but a C++ string is different from a C string, i.e. this is the improvement that C++ gives us, is that we actually also have the length information available to us inside of the string object, inside of the string container. In C, this didn't exist, which means that every time you need to figure out the length of the string, you have to figure it out from scratch each time new. So you would have this function called strlen, strlength, and you would put your string in. It would have to go from the beginning and go all the way until it reached that null terminator, count the number of characters, to get the actual length of the string. And in C++, we said essentially, hey, this is pretty inefficient. We can store that number right inside of the string so we can look this up quickly and not have to do this every single time. So that also gives us some basic ideas in terms of how does the string iteration work behind the scenes. Well, the way that it works is that we know where it starts and we know where it ends. And what we're going to do is each time we're going to call next, we're going to move the start over to the next character. And what that gives us back, it gives us a char, a char type. You've seen integers, we understand what those are. We've seen doubles, we understand what those are. And the string, you've seen those, but inside of the string, it's just made of a sequence of char, C-H-A-R. What is a char? A char is actually a sort of type of integer that can take the values from 0 to 255. Sometimes it's also called an unsigned integer, but really it's actually an unsigned byte, because that's just as big as it is, the size of a byte. And inside of it, it stores a numerical value. What that numeric value means is up to interpretation. So when we're saying that we want to treat that numeric value as a char, C-H-A-R, then we're going to get a character put out onto the screen or whatever operation we're dealing with. But we can also tell the compiler, we could also tell the program to think of it as an integer. It really depends what you want to do with it, and then you're going to get the numerical value of it. There's something known as the ASCII table. The ASCII table is a standard that prints out or gives us all of the values of the different characters available to us to use. This is fairly old, but you can look this up. So let's say you want to know what the value is of the character L. You can see that the decimal value for it is 76. On the other hand, if you wanted to look the value for the number 7, that would be 55, and vice versa. And you can interchange between these two types of values. Values below 32 are sort of reserved. We don't really use them, and the values above 127 are also used for other things, some more special characters. And if you're coming from, let's say, an Asian language or an Arabic language or some other languages that obviously have much more characters, that tends to fall into different character types, sometimes called either a wide character or a Unicode character, which are bigger to be able to store more information. But we'll talk about that maybe later on in the course, and we'll examine those later on. But for the basic examples, you can just think of this as the ASCII character table as the ASCII character set, and that's what we're going to be using.